Hi guys, this is on page 10 of your book, and this is the lesson that I would have been doing if I met with you today. I'm going to do a very short lesson with you. We're just going to do a little bit, but I don't want us to fall behind. So what we're going to do today is called imaginary and complex numbers. So an imaginary number is basically if you take a square root of a negative number. That's not possible in the real number system, so somebody made up imaginary numbers. So the definition of it is the square root of -1. Okay, so there is no number times itself that gives you -1. But someone made up a number called I, and if you square I, you get -1. So I squared is equal to -1, and I is equal to the square root of -1. So that's called an imaginary number. It's a number that can be written in BI form. B is real, I is imaginary. So example 2i would be the square root of -4. 5i root 3 means that it was a radical that needed to be simplified. Actually, that's the square root of -75, because you would break that down. Well, when you're breaking down a negative under the radical, you put an I first, and then you basically just break down a regular 75. And then this becomes a 5i root 3. All right, so basically if there's a negative under the radical, I has to go with your answer, and the rest of it is just simplifying a normal radical. We only use I with square roots. There's no such thing as an imaginary number with cube or fourth or fifth roots. It's all for square roots. A complex number is basically a binomial that is part real, part imaginary. So 5 plus 2i would be called a complex number, but even 6i you could think of as 0 plus 6i. So that's still complex. I mean, really 6i is just an imaginary number, but you could write it as a binomial of 0, the real part, plus the imaginary part, 6i. We always write them in what's called a plus bi form, which means you put the real part first and the imaginary part second. So if you took the number 5 plus 2i over 3, you would write it as 5/3, because that part's real, plus 2/3, and then the I over there, that would be called A plus BI form. Okay, we always write our answers in that format. So every time you have a complex number, put the real part first, the imaginary part second. So this is how we do it. If you have a negative under the radical, that means your answer is imaginary. Since 36 is a perfect square, you would just write 6i. For number 2, you have a coefficient of 2. Because of the negative, you're going to pull an I out and then just simplify a regular 75. So whenever you see that negative under the radical, you're basically going to bring out the letter I. So now I'm going to break down 75 to 25 and 3. The 25 becomes a 5, and then that gets multiplied by the 2i, so it's 10i times the square root of 3 would be your answer. So it's the same as simplifying radicals, you just have to put an I with your answer. So for the next one, this is a perfect square 16, so that's just going to become a 4i, and then it's minus 9. So this would be 12i minus 9. But when you have a binomial, you want to put the real part first, because you want what's called a plus bi form, and the directions will always say that, and they do here. So you want to rearrange this and write -9 plus 12i. For complex numbers, order does matter, and you want the I second. So for number 4, you're going to leave your -4. The negative under the radical is going to pull an I out there, and then you just break down 27. So you have -4i multiplied by 3, square root of 3. So it's -12i root 3. Since it's a monomial, you don't have to worry about a plus bi form, but you might say, well, why can't I just write it like this? You can. The problem is the I should not look like it's under the radical. So I always end up putting the I in the front of the radical so that it doesn't look like it's under the radical, because this is wrong. The I is not under the radical. So if you put the I at the end of the number, it can look like it's in the square root, even though it's not. So that's why we put the I in front. But, for number 4, this doesn't apply to a plus bi form because there's only one term. A plus bi form is when there's a part real and a part imaginary of a binomial. All right, we're just going to do a couple more examples of adding and subtracting. It's the same as, all our other ones where you have to have like radicals to combine them. So you simplify first. So this would become a 3i, and then you would break down the 80, which would be 16 and 5. So the first one would be 12i root 5. The other one is a minus 2i. You take out the I because of the negative, and then 4 and 5. So that's negative 2 times 2 root 5, which gives you negative 4i root 5. These are like terms because they both end with an I and a radical 5. So 12 minus 4 is 8. The answer is 8i root 5. It's not a binomial, so you don't have to worry about a plus bi form. Okay, I'm only going to do one more, which is number 6. So it's going to be 5i, 16 and 2. And the 50 is not imaginary, it's just 25 and 2. So this becomes 5i times 4 root 2, which is 20i root 2. And that's 5 radical 2. Okay, even though these both end in radical 2, you cannot combine them because one's real and one's imaginary. But you do have to do a plus bi form, which means you got to put the real one first. So your final answer would be 5 radical 2, which is real, plus 20i root 2, which is imaginary. That's a plus bi form. All right, so I'm only going to give you these other 4 problems on this page to do for homework. It's on page 11. And it will be due tomorrow if I have you tomorrow. Let me check. I think tomorrow. Yeah, tomorrow's a D-Day, so I do have you. So this homework will be due, before your class, and your class meets at 9:30. Sorry. So this will be due by then, and that's it. All right.